Lurking in the farthest reaches of the cosmos, black holes are the most terrifying and fascinating objects in the universe. They are not just regions of space where gravity is strong. They are cosmic abysses, where the known laws of physics begin to collapse. A black hole is formed when a massive star exhausts its fuel and collapses under its own gravity. If the core is massive enough, it compresses into a single point, a singularity, where density becomes infinite and space-time curves infinitely. At this point, everything we know ceases to work. Surrounding the singularity is the event horizon, the boundary beyond which nothing can escape, not even light. Once an object crosses this invisible line, it is lost forever. But what happens inside the event horizon remains one of the greatest unsolved mysteries in astrophysics. Time itself slows to a crawl near the event horizon. To an outside observer, objects falling in appear to freeze in time, forever approaching the boundary. But for the object falling in, time proceeds normally, and the singularity awaits. Some theories suggest that black holes may be gateways to other dimensions. Wormholes, as described in Einstein's equations, could theoretically link distant parts of the universe, or even alternate realities. Could falling into a black hole transport you elsewhere? Others believe black holes are destroyers, not portals. The gravitational tides near a black hole are so intense they would stretch you into a thin strand of atoms in a process aptly named spaghettification. No known object could survive the journey inward. Yet black holes may not just consume, they might also create. Stephen Hawking proposed that black holes slowly evaporate over time, emitting radiation, now known as Hawking radiation. If this is true, black holes don't last forever. Over trillions of years, they may shrink, flicker, and vanish in a final burst of energy. But what happens to the information they contain? This leads to the black hole information paradox. In quantum mechanics, information can never be truly lost. But if a black hole destroys everything inside, where does that information go? Physicists have been battling this paradox for decades. One idea is that information is encoded on the event horizon, like a hologram. Another proposes that black holes store data in hidden dimensions. Some even suggest that black holes could be cosmic hard drives, archiving the history of everything they consume. And if black holes evaporate, is there a moment when they release this information back into the universe? This is not just theoretical. It strikes at the core of our understanding of reality. If black holes can erase information, the foundation of quantum mechanics may crumble. But if they somehow preserve it, we may discover new laws of physics that unify gravity and quantum theory. Recent observations by the Event Horizon Telescope have given us the first real images of black holes, silhouettes of darkness against glowing cosmic light. These images confirm Einstein's predictions, but raise even deeper questions. Could there be miniature black holes created during the Big Bang? Might they be scattered throughout the universe, invisible but influencing matter and energy? Could the universe itself have begun inside a black hole? At Infinity Beyond, we follow these questions to their farthest edge. Because black holes are not just cosmic oddities, they are keys to unlocking the deepest truths of the universe. They challenge our notions of space, time, reality, and even existence itself. One day, we may understand what lies beyond the event horizon. Until then, we watch, we measure, and we wonder. Because in that wondering, we grow closer to the truth. And the truth, as always, lies far beyond the stars.